Okay, hello everybody, and good morning. So today I'm just continuing the second part of my webinar, the part two, how to practice. We have what we have learned from the part one, the concepts of text mining and natural language processing in Python. So we did talk about the concepts of NLP and TM, the basics of them, and then now today we have the Python, how to practice those concepts. So some people might ask why Python. So there are several reasons for that. It's an easy, expressive, OOP, and dynamic, and then embeddable, extensible language. It's the perfect language for scientific purposes and research. Otherwise, if you're looking for like real-time systems, or so you might go to with the C or C++. Otherwise, the Python is good for scientific and research purposes. So there's a bunch of libraries for NLP and text mining. And everyone has its own features. So Spicy is good for industrial if you're looking to make a commercial product for NLP and text mining, then you'll go with a Spicy, as it is the fastest one, as they show it in their website. Like they had a benchmark and they've tested with and they compared it with the others. You got the core NLP, it's Java based, but it got some Python warpers, so you can do it in Python. And then NLTK, that's just perfect for educational. It's just well documented, and then the most of the NLP tasks are there. Then the Gensum, it's a semantic-based machine learning framework for like topic modeling and semantic modeling. Then PyNLPI is an extensive like library for XML if you want to go with the XML. And text block, you do multi-purposes NLP. And then patterns, if you want to go with the web crawling, you're going to use it. Then polyglot, if you do with the multilingualism, you're going to need it. And the vocabulary, if you do with the information retrieval systems, you work with that, you're going to need it. So today our practical demo of Python text mining will follow the same pipeline of the traditional data mining and data science steps. So we go with the data selection. You're gonna have a text, like some text to cluster, and then we do pre-processing. Then we transform our text to numbers, and then we mine our numbers with k-means. Then we're gonna evaluate our results. Before going into the code, let me ask you this question. So when we do document or text clustering, what the result will be useful for? So, or before that even, so what kind of application is that? Is it going to be a descriptive application or predictive? So which class of application is this? Are we describing a data or predicting a data, patterns in a data? So it is definitely a descriptive application of text mining. So you already have a data, you describe it, what are the clusters and groups of documents are there by topics. So we're not predicting any new input in the data stream. So that is why it is the descriptive application. Then the results of document clustering or semantic clustering potentially are many. So this is my old list from my webinar one. So these are the long list of the text mining applications. So the one bolded in blue are the potential applications of after doing document clustering. Okay, so now let's go forward. So we can have a corpus like this, 7 or 8, 10 lines of text. Every line we're going to consider it as a document. Then we're going to do a clustering on them. So for the data transformation, we do transform them to numbers, to TF-IDF table. that is the term frequency inverse document frequency. It's a numerical representation of the textual data, like string data, into tables that can be given then to the K-means algorithm for doing clustering. So for more information, just refer to Wikipedia page of the TF-IDF. So so the basic TF-IDF table is like this. So every row is a document, and every column is a feature in the semantic space. By feature here, I mean a unique term in the corpus. So this is a list of unique words in the corpus we have been using, for example. And then we got 7 or 8 documents. So for example, the word basketball has the weight of 0.4. The word basketball, that's the second word, so not this, not this. So it's 0.3 in the document 1, and then 0.0 in the document 0. So it means in the document 0, the word of basketball, it does not appear at all. So so these are the weights of the importance of the term inside each file and overall the corpus. Then this table is given to the K-means algorithm to cluster them. So the K-means is very famous and very efficient algorithm, being still used by in industry and commercial products. You got very variations, but the basic algorithm is this. So it goes with 2 steps of assigning the data points that are our documents to clusters based on the initial centroid, then choosing centroids, like new centroids for the clusters, to reassign the data points, the documents, to new centroids until the centroids do not move. So that is the basic concept of K-means algorithm. So let's say we got these set of data points, and we want to cluster them to 2 sets, 2 clusters, 2 groups. So we select 2 random centroids, one blue, one red here, one blue here, and then based on their distance, that is the Euclidean distance or cosine, whatever the distance metric is. So so for the first iteration, this set of points will be turned to blue, that are the closer one to blue than the red one. And then the second iteration, the second step in the first iteration is to recalculate the centroids. So centroids will move toward those clusters, those set of points in each side. So the blue one will come here, and then the red one will move forward, downward, and then we're gonna reassign the data points after moving of the centroids. So all these red ones will turn to blue, or these blue will turn to red. And then that way we're gonna come up with 2 pure clusters of data points. So this is in the case we do have 2 data points, 2 clusters, 2 centroids. We might start with like finding 4 or more or less centroids. Then the K-means is able to cluster our data points to subsets and subclusters. So the default distance metric in K-means is Euclidean. Is based on the Cartesian coordinates. You can refer to it. It's just Google for it. You can find it in the. There's a good article in the Wikipedia about it. And then after the K-means is done, our documents will be clusters. So the cluster 0 and cluster 1. So based on the topic and the words in the sentences, let's say in the documents in our case, every line will be assigned to a cluster. So this one, student, and here's also about school and student, and then here's about teachers, here about students, all are assigned to the cluster 0, 0, and 0. And then the others, basketball, play, team, all will be assigned to the cluster 1. So cluster 1 about school and cluster 0 about the sport. And then we evaluate our clustering by the metrics of precision, recall, and F1 and F1 score and the support. And I have been explaining these metrics in detail in the webinar part 1. You can refer to it. Okay, let's move to the coding part. So I'll be using the PyCharm IDE. You might have any other options, it's okay. So I'll create a new project. So I'll name it document string. So let me create, so I just created a project. We need a Python file. So new Python file, you just name it. So we'll go with the steps we use to data mining. So we're gonna have first to load Corpus, and then pre-process text, and then transform text, and then cluster text, and then evaluate clustering results. So for here, you're going to use IDF. Sorry, so here we're going to have like punctuation symbol and stop word removal. Yeah, you're going to have IDF. You're going to have k-means, and then you're going to have precision, recall, F1, and support. Okay. So of course, up here we're going to import your Python packages. So let's go with loading the corpus. So we're going to make, let's call our main function. We might have some helper functions up there. So let's call our, okay, so there we go. So here we're calling our main function, and here's the main function in Python. So let's define our corpus. So corpus, let's name it corpus. I'm gonna have a lot multi-line text. So let's do it like this. So the students went to their new school. So every line here is a document. We can consider it that way. So you might import your corpus, text corpus from your Windows or Mac directories, or you might just load it from the SKLearn and Jensen frameworks. They already they did define the corpus, the famous corpus that people use to perform text mining, sentiment analysis, and natural language processing. So then you have to import the libraries, the packages for loading those text corpus. But for simplicity, we just go with a simple corpus like this. So every line is a text document. Then that was the best basketball player in the city. Then next week, this basketball league will start. Then the pool is starting their classes today. So best team from, let's say, University of Zahor will play with the best team from University of Duhok, let's say. Then teachers were so excited to see their new students. And then, hello, students. Here, the school principal. Then, did students start to play basketball from day one? Okay, so we got a mixture of documents. So this is about school. This is about sport, right? School, sport, school, you know, school and sport. So sometimes it just very often when you're gonna have a document piece of text that belong to more than one topic, it's just super okay. So this is our text corpus. Let's transform this to an array of documents. We're gonna split it by new line and then just stick letter. So let's just print it. Let's see how it looks like our text corpus. So print corpus. So let's say print text corpus. Say input text corpus. That looks like. And also I can print here, let's say print size of corpus. So like how many documents we do have. Okay, let's run it. And go to run. Okay, here's our corpus. Every line is a document, and we got 8 documents so far. So let's move to the pre-processing step. So by now we loaded our corpus. That's the first step in data science. So you have to have your data in your hands, and then we're gonna do that pre-processing. So pre-processing, you can remove numbers. Maybe you do have HTML tags if you have HTML files as your text corpus, and punctuations. So we're gonna delete the punctuations we do have here. So for example, we have question mark, we have comma, dots, different kinds of punctuation symbols. So we're gonna remove them. So we need to So from string import punctuation. So we're gonna omit these punctuations from the corpus. So in this set of punctuations we have there, let's just see what kind of punctuation we are able to remove. So you can remove any of those punctuation symbols from the corpus you do have in your hands. So let's do it. So for any document in enumerate corpus, so result combine. Okay, for any character or character in document, if character not in punctuation, then corpus, because we assign the document to the same index after omitting the punctuation symbols. So result, then let's just empty this variable, and let's print again. So text corpus after punctuation removal. That's how it looks like. So now you do see here the question mark, the dots, the comma, everything is omitted and deleted from our corpus. So far we did a little bit of pre-processing. So those symbols, punctuation symbols, do not have very explicit semantic meanings. That's why, for the sake of computation, runtime, we do, and the semantic space to reduce it, we do omit them. So imagine you have millions of documents, we can come up with hundreds of millions of symbols. So just omit them. Okay, so then we need to delete the stop words. So stop words, for the stop words, we need to import the stop word list. So we say from NLTK corpus import stop words. So we're gonna remove the stop words from the corpus. Stop word like to, like the, was, is, those prepositions, they also do not have very explicit and very rich semantic meanings. They're not gonna contribute very heavily in the semantic clusterings of the document. So that's why we can just exclude them from the whole process. So let's do it. So now we're gonna remove stop words. So what stop words we do have? So let's print them. Stop words already, we have them from the NLTK library, the package. So you can just see very quick list of stop words we do have. So stop words dot words. So the language is English. Let's print. The NLTK supports some other languages, European languages, but you can have your very own stop word list. You can just make a Python list and pass it to your text mining and natural language processing pipeline. So here's our long list of the stop words. So all of these, like I am, like I, me, my, blah, 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 blah. all of these words will be excluded from the text mining pipeline. So wouldn't. Okay, so let's just remove the stop words. So for that purpose, we're going to use the TF-IDF vectorizer. We can do it manually, actually. Just go through your documents, document by document and word by word. If it's not in the, if it is in the stop word list, just exclude it the same way we did for the punctuation removal. Let's do a shortcut. So we go SKLearn TF-IDF matrix. So let's go include a TF-IDF vectorizer for the process, for the purpose of the stop word removal. So here we're gonna have SKLearn. So from SKLearn, feature extraction, and then text, import what? TF vectorizer. So it will do multiple things for us. It will tokenize the words in the document, like turn them to lowercase, and then also we will tell this method, this function, to omit the stop words from our corpus. So do we want it to? Okay, so do we want it to remove to turn it to lowercase? Yes. And then, so tokenizer, you want it to schematize it or lematize it? I'll define it soon. And then the stop word. So we're gonna have our list of stop words dot words of English language. So we can do lematize or schematize the corpus. So by that we mean, let's just go show you very quick. So another example from the Towards Data Science, a very good website. So so here we got like the changer, all change to, and be like change. And then on the other side, the lemmatization will turn them to change, at the very root of the word. Okay, so let's do. You can. So it's up to you. So you can do a small experiment to try lemmatizing and also schematizing your corpus and see the results. So which one looks better? You can just try it. So let's go with the lemmatizing. So NLTK, tokenize lenses. Okay, so so we need to define this function to use it for our TF-IDF vectorizer. So let's just define this function. Okay, so we will receive our text, the function. Then this function will need to extract all the tokens in the text. So NLTK TK dot NLTK dot word. So we have not imported that library yet. So we'll do it here from, import NLTK. Here we go. The natural language processing package. we are using it. So here we go. Dot word tokenize. They will split our text to tokens, like single words. Then you're gonna lematize those tokens. Lematize those tokens using tokens. We just extract it from the text, and then the lematizer. Then we're gonna return our lematizer. So I'm going to define the function to do the actual lemmatization. So def or the okay, so yeah, we need to import this actually. So lematizer, we need to import it. So the lematizer, we're going to use the word net. So word net, it's not coming, so just import it. So we can use that word net lematizer. So again, from NLTK, NLTK and him word net import. We're gonna import from there what? The word net lematizer. So here we go. If you want to have a steamer, so you need to import the steamer. So that is from NLTK again, and steam, then import steamer. So okay, so it's down. So we just made our object for doing lemmatization. So I'm going to use our object of lematizer. So we need to define this function that will actually do the lemmatization part of the work. So lematizer, the tokens, it will receive the tokens, then our object of lematizer. Okay. So lemmatized words, list of lemmatized words. So for each item in tokens, do the lemmatization, please. So append lematizer, lemmatize our item. Then when you're all done, please return the lemmatized tokens. So okay. So before we define the lemmatization functions, perform the lemmatization of the tokens in the corpus. So there you go. So now we can see, we can transform, we can go to the transformation part. So we can, so this is a tokenization for the purpose of generating the TF-IDF matrix. So we can use this object to do the actual generation of the TF-IDF matrix. So TF-IDF matrix equal to dot So fit transform, we have to pass our corpus to here, right? So the corpus will go here, but it has to be a dictionary, not an array. So a corpus is an array of strings of documents. Let's convert it to a dictionary. To do that, so we need to transform array to dictionary. We say corpus array to dictionary. Corpus dictionary. Okay, so we're going to do it here. Okay, so document, let's name it tokens dictionary. So this is the way we define the empty dictionary, right, in the Python. So for every document in corpus, we're gonna add it to our dictionary. There we go. So our dictionary is ready to be passed to the transformation function to generate the actual TF-IDF metrics. So we don't pass the whole dictionary, just pass the values, right? Like the documents, because the keys are the file IDs of the corpus. So we just pass we need to pass the values of the dictionary. So now we have our TF-IDF metrics in our hands. Let's print it, the content. Okay. So print but before that, let's see what are the features of our TF-IDF semantic space. So let's print also the file IDs. So file IDs we have, so keys. So let's print the keys of like the names of the files in our corpus. And then print the terms in our semantic space. Okay, so print terms, the features, TF-IDF metrics. So get feature names. So let's print, see what we got. So we'll be printing the file IDs and the features, the unique words in the corpus. Which are the two dimensions of the TF-IDF matrix. So it is document by word. Okay. There we go. So this is the corpus after punctuation removal. And then here are our file IDs. So file ID, document by the terms. So this is the semantic space of the corpus. So we get every unique word in the corpus. So these documents will be clusters based on the importance of every word in each document and overall the corpus. So let's print the actual TF-IDF matrix. So we have not started the k-means algorithm yet. So let's print. So TF-IDF matrix. So print for every row in range of 0 to length of, like, how many documents we do have, the size of the dictionary of the corpus. Then we're going to print file IDs, so here's our iterator. So we use our I, and then we're going to use the list comprehension is a way of shortcutting your code in Python. So in around numbers for each weight to be like 2 digits, and for every weight in TF-IDF matrix, we're going to transform it to array. Yeah, so TF-IDF matrix to array, and then we're going to, for each array of I, we're going to convert it to a list. Okay, so let's print it. We will be printing the content of the TF-IDF matrix. Let's just print the content of the TF-IDF matrix. That is, it's document by term. Okay, so TF-IDF matrix is a 2-dimensional matrix of numbers that is ready to be passed to the k-means algorithm to cluster the documents based on that, the numbers in that matrix. So here we go. Here are the IDs of the files. So we got 8 files from 0 to 7, and these are the features. So every term, unique term, is a feature in the semantic space of the TF-IDF matrix. So yes, so for the k-means algorithm, we have the Euclidean distance, the default distance metric for the k-means algorithm is Euclidean. You might use cosine or other. We got a long list of distance and similarity matrices can be used. So for the SKLearn, the default distance metric is the Euclidean. So imagine this is a 2-dimensional space of Cartesian coordinates. So P1 and P2 are 2 documents. So so P and Q, every like P is a document, Q is a document. So how to measure their distance of 2 documents in the 2-dimensional, let's say, space. So just the square of subtraction of the points that get to the P1 and P2. So that is basically every line. So we will go like, okay, so this is let's say this is P and this is Q. So this is P1, Q1, P2, Q2, P3, Q3. So that way we'll go until we go to the end. Then so the result will be how much distant are these 2 data points in the semantic space. So P1 is a document, P2 is a document. So how much apart are those 2 documents in the whole semantic space? So far we came up with the IDF matrix. So now we're just ready to go to do the actual document clustering. So we'll be using the K-means algorithm. So for that purpose, we need to define the number of clusters. So it's up to you. So let's go with 2 and see if our let's say our system can cluster those 8 documents into 2 correct clusters of 2 topics that were the sport and students, if you remember. So now K-means equal K-means. So we have to import this actually. So go up there, and we need to include. Okay, so from SKLearn dot cluster import K-means. So mini batch K-means. There are very many variations of the K-means. So let's go with the basic one. You can do experiments and see how they look different. So here we can go with the K-means algorithm, the basic version, just to test our system. So we passed the number of the K-means clusters that we're looking for. So we say here the number of clusters then we're gonna do the fit. Then you're gonna pass our IDF matrix. Let's print the results of the clustering. So we go to print the results. Let's just name it results equal to. So we're gonna make a pandas data frame. So let's define or import the panda package here. So import pandas as panda. Okay, so we're gonna make a data frame to organize our printing results. So results. So it's a data table. We can have a column, say documents Mantis equal to Corpus, then results, the second column, the cluster, let's say ID, equal to K-means labels. So let's just print. So results of clustering results. Let's print. So here we got our corpus, main corpus, and then after pre-processing, and then file IDs, semantic terms of the corpus, and the terms of the corpus, and the TF-IDF matrix, document by words, and then the results. So here we go. You can see here that the documents are clustered by topics. So here, the document about students, it has been clustered to the cluster 0. The other one about school, the other one about school, the other one about school, and all the ones about sport have been clustered to the cluster 1. So basketball, team, play. Even this one it talks about students. It's a mixture of topics. So it's about school and it happened to be some sport there, like play basketball. So because we got more words about sport in this document than the words about students, so it has been clustered to the topic of sport. So finally, we will go now with evaluation of the results. So how much accurate are these results? So imagine you got hundreds, thousands, millions of documents. So it's not like this easy peasy. You just look at the documents and you read, you see, okay, my clustering is correct. So that's why we need a computational way of, like, we need some functions to do it for you. So for that, we will use the SKLearn package that has a set of evaluation metrics people use to do evaluate the clustering and classification or whatever data science and mining tasks you do have. So now we go with the from SKLearn metrics import precision, recall, F course, and support. We can use the 4 methods. So we can evaluate the clustering results based on four clustering aspects. So for that purpose, we need to have our benchmark there, right? So let's say predicted. So let's say predicted clusters, and then we have the actual clusters. So you're going to compare them, right? So let's say here, let me just add the clusters for the actual cluster assignment for the documents. So we're going to go with so 0. I'll put zeros for the school and student related topics, and then the 1 for the sport one. So I'll go like this: 0, 0, 1, 1. So this is about school, sports, school, right? This is school. Yes. So now we'll just look at the full sentences, the full documents. So schools, sport, school. So 0, school, school. So these 2 documents are a little bit tricky because they do talk about schools and sports. So first one, school, sport, school. Okay, so and then this one, let's assign this. So for us, this document is it does belong to the topic of sport, so that's why we're gonna mark it like 1. Then this one, but we're gonna see like how much our clustering is efficient to cluster this to the right one. So and then comes the school one, and school, then sport. So 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 documents. 1, 2, 3, 4, 5, 6, 7, 8. So one more time. This is the this is the actual assignment of the documents to clusters by topic of the writer. So it depends on the nature of your application. So if it's articles from news streams like BBC or CNN or whatever, so they already have tags on it, right? So like which article belongs to which category. Or if you have like papers from conferences and journals, so already they got some tags and keywords on it, right? So you have to have a benchmark in your hand, like for the clustering purpose to evaluate. So this is why we do have we are making the actual tags and clusters for the documents. So students, one more time, we just double check. So students, so the one about school gonna have the 0 cluster, the cluster with the number 0. So school, and then sport, school, right? Then sport, yes. Then school, and school. So all these 3 do belong to the school ones. Okay, so we got 3 zeros here. So now let's evaluate. So for that purpose, so the predicted clusters are k-means dot labels, right? The ones we just printed here. So these 0 and 1s. And then we just have to put the results, like these results, in some variables to compare them, right? So recall for a session, recall F score, and then support equal to score, and we just pass both of them. So pass this with predicted clusters. Let's import the class of score, this class of score. So let's import it here. Okay, so import as score, right? So here we go. We just need to print this stuff here. So we just print them. And then let's print them separately. Print. Okay. So print. So print evaluation results. So print session. And print print and the brackets. So we get like nice format. 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 Okay, so let's print these results. So meanwhile it's printing, let me go back to the slides. So here we got the categories after clustering, and then here the precision, just to remind you, is it tells us how many of the selected documents in a given cluster are relevant. So they're relevant together to each other. The recall tells us it answers the questions of how many relevant documents are selected in a given cluster. Then the F-score tells us the accuracy of the clustering overall. Okay, so let's see how it has been clustered by our algorithm, K-means. So 0 is correct. It is 0. Just sum this up. Okay, so this is the actual one. So 0, 0, 1, 1, correct. 0, 1, 0, 1, then 0, 0, 0, and 0, correct. They do belong, this and this. These two documents belong to school ones, but the K-means got confused about the last one, so it did cluster it to the student topic that is actually for the author, for us, let's say the corpus maker, it does belong to the sport one. So that's why we see here the precision for the cluster of 0. So this is precision for cluster of 0, the recall for the cluster of 0, F-score for the cluster of 0, and then the so precision recall F-score for cluster of 0, and then the second value in arrays are for the cluster of 1. So yes, so we got better results for the cluster of 1, of the 0, sorry, than the 1. And here support tells us how many documents we have in the cluster of 0, and then how many we have for the cluster of 1. So the total is 3 plus 5, we got 8 documents. So this is the way we do print the results of the clustering, and then we just evaluate the efficiency of the system, of the whole overall data mining process you have. So thank you for watching, and I hope you enjoyed the video and learned something from it. So again, if you have any question, just leave it in the comment section and just let me know what you think about the video. Then thank you.